The project is on named entity extraction for English contracts documents. It is a research and development project. Our supervisor is Dr. T. Uday Shankar, and we are team Apocalypse with Madangi, Kayanan, and Tayaruban as the team members. Why this research? What happened with the existing model? The current state-of-the-art model, BERT NER, fails to provide satisfactory results when applied to NER in legal contracts. The reason for this observation will be the unique language and structure of legal contracts, characterized by the presence of legal jargons and varying references to named entities. Legal contracts often utilize specialized vocabulary and terminology that are not commonly found in general text. Lower FM scores were demonstrated by the older existing NER models compared to the general domain. I'll walk you through the motivation behind our research. First one is automate the contract analysis and facilitating better understanding of legal documents. Automating contract analysis saves time and cost, enables informed decision making, mitigates risks, and ensures compliance. Our research aims to open a new efficient path for domain adaptation, reducing time and cost requirements in the process. Objective of our research is to accomplish the following. The model was developed to extract basic named entities, person, address, place, and organization from English contracts text. The focus was initially placed on these entities due to limitations observed in existing models like BERT NER when it comes to effectively extracting them. The challenge posed by out-of-vocabulary words, which are words not present in the model's vocabulary, is recognized. Our objective is to develop techniques to effectively handle out-of-vocabulary words. Our objective is to implement efficient tokenization methods tailored for English contract documents to improve the performance of model for named entity extraction. Optimizing the tokenization process enhances the model's ability to accurately extract named entities from contract text. Fine-tuning BERT for NER on our dataset is our baseline. On average, baseline model achieved the following performance metrics. You can see. What is our approach? The aim of our approach is to improve NER accuracy for legal contracts by using domain adaptation through adaptive tokenization with BERT. So our research is focusing on the effectiveness of adaptive tokenization in enhancing the performance of BERT NER. Inception tool is used for annotation of 250 contract documents collected from CUAD. Now let's move on to the methodology. Based on our literature review, it was found that domain adaptation is considered a more efficient approach compared to training the model from scratch, as it conserves computational resources. Among the domain adaptation methods, adaptive tokenization was specifically chosen by us. Within adaptive tokenization, the method of adaptive vocabulary selection, which focuses on the statistically derived domain-specific subword tokens, was selected. This approach utilizes the statistical properties of the domain to derive subword units for improved performance. Our methodology is, firstly, we select domain-specific subword tokens and then augment it to the vocabulary, then initialize embeddings for augmented tokens. Finally, fine-tune BERT on our dataset for NER. Now let's look at the first step of our approach, finding domain-specific subword tokens. In order to identify domain-specific tokens, various techniques can be employed. Out of those, we are using comparing the token distributions between the target domain and the general language model can help identify domain-specific tokens. The conditional probability of tokens plays a crucial role in this approach. we analyze the conditional probabilities of subword tokens to identify domain-specific terms in the legal contract domain. For example, if the subword token object is specific to the legal domain, conditional probability will be high when compared to a non-domain specific token like obligation. This allows us to pinpoint subword tokens that are more indicative of the legal contract domain, which in turn enhances named entity recognition tasks in this particular domain. 3 different statistical methods are employed to assess the domain shift between the target and base domains based on the conditional probabilities of subword tokens. Among these methods, the most promising results were obtained from the Kolmogorov-Smirnov test. This allows the effective detection and analysis of the domain shifting subword tokens between the legal contract domain and the base domain. To address the issue of undefined values in the Kullback-Leibler and Jane-Shannon divergence test caused by rare or unseen token sequences, smoothing techniques such as Laplacian smoothing and Dirichlet smoothing were implemented. These techniques introduce a small pseudo count or to all tokens, ensuring non-zero probabilities for even rare or unseen sequences. The second step of our approach involves adding the identified subword tokens with higher domain shift to the vocabulary. By selecting the largest substring found in the vocabulary at each subword unit during tokenization, the tokenizer incorporates domain-specific subword tokens into the vocabulary. So, if we see indemnification can be tokenized this way, and after adding indemnification to the vocabulary, it will be tokenized this way. Similarly, the major and confidentiality will be also tokenized after adding to the vocabulary. This changes enhances the model's capability to capture domain-specific information, leading to improved performance in the target domain. Next, I'll move on to step 3 of our approach, which is initialization. In the third step of our approach, we explore different techniques for initializing the embeddings of newly added tokens. These techniques included average embedding initialization, normalized average embedding initialization, and renormalized average embedding initialization. After conducting experiments, we found that the average embedding initialization techniques yield the best results for our approach. We incorporate our annotated NER dataset to train and fine-tune the model. Next section covers the experiments conducted and the corresponding results obtained. The approach achieved a notable improvement compared to the baseline. Experiments conducted in the finance and news domains also demonstrated performance enhancements. While the improvements may be relatively small, they are significant and highlight the effectiveness of our approach in enhancing NER performance in the legal domain. The KS approach outperformed both KL and JSD in detecting domain shift. When employing smoothing techniques to handle the out-of-vocabulary words, it produced a noticeable improvement when compared to the approach without any form of smoothing. The average embedding initialization yielded superior results in comparison to other techniques in initializing embeddings for the newly added tokens. Experiments showed varied improvement across 3 domains, with the legal domain exhibiting the highest enhancement. This difference can be attributed to distinct language patterns and clear distinctions in legal texts compared to news and finance. Label data availability and the unique characteristics of each domain may have influenced the observed performance gains. The adaptive tokenization technique with the KS algorithm outperformed JSD and KL divergence in our experiments, accurately identifying domain-specific tokens not in the original vocabulary and improving domain adaptation. KS algorithm focuses on extreme differences between token distributions, pinpointing tokens that contribute to domain-specific characteristics and enhancing language model adaptation to the target domain. In conclusion, adaptive tokenization approach enhances BERT's domain knowledge acquisition by tailoring tokenization to specific domains. KS analysis outperforms KL and GSD in identifying domain-specific subword tokens. Implementing smoothing techniques improves rare word handling. Our project explores NER for legal contracts, domain adaptation, offering new research avenues for adaptive tokenization in domain adaptation. Thank you.